podcast focused on trends shaping the future of manufacturing. I'm Alexandria Burek, your host, here with A.W. Schultz, two thought leaders with a passion for people and manufacturing. Today and every episode, we are diving deep into the advancements, sustainable practices, and dynamic changes transforming how we produce everything.
And now welcome Alexandria Burek and A.W. Schultz.
Well, hello everyone. Welcome to another episode of Factory of the Future. And I'm here always with Alexandria Burek and myself, A.W. Schultz. Today we have a special guest, Paul Susalla. Paul has a very interesting and impressive background. Paul is the Vice President of Advanced Manufacturing Engineering, Progressive of J.P. Poindexter & Company, Parker Hannifin, Ford, and General Motors in his career. A globally recognized leader with over 35 years in automotive and industrial manufacturing. Paul has been known to excel in the robotics, automation, additive manufacturing, and Six Sigma processes. Holding several patents, which we're going to be talking about, and several awards, 22 to be exact, several publications, Paul is known for his ability to transform operational through technical and collaboration teams. What you can expect to talk about in this call today is a little bit about the hidden factories. And we're going to be talking a little bit, especially probably in the automotive industries with Paul's background, a little about Lean Six Sigma and some of the patents that Paul has been a part of driving process efficiencies. So Paul, I want to welcome you to the show, and we're very excited to have you.
Thank you.
So as we get into this, I met Paul on an executive roundtable a while back. And one of the conversations we got tied into was a term I hadn't heard in probably a couple of years, which is sad because it's out there all the time, which is the term hidden factory. And if you can, Paul, can you explain a little bit to some of our listeners that may not be in the automotive industry or high-speed automation, what is the hidden factory?
Sure. Hidden factory is not just for automotive or high speed, it's for every process, really. So if you think about making a product, it goes through multiple steps. It starts with raw materials or whatever, and the end of it is a finished product. If it doesn't go through every step cleanly and as efficiently as possible to the end, that's the desired result, that creates what we call hidden factory. So if a person has to rework the part or it gets routed, for repair, that's all, again, what we call hidden factory. It's waste. It's stuff that shouldn't happen. And the reason we call it hidden is because a lot of times it's not identified. It's costs that people just assume are part of the process, and it really isn't.
Do you have any examples that you could share about where you've had to seen this hidden factory and have to diagnose it? Or maybe as you've gone into different facilities, how have you recognized that they've got a problem with rework and waste? And
right. One of the easiest ways to find a hidden factory or find out that you have it is just long-term observation. Stand there and watch the process. If parts aren't going cleanly straight through to the end, you have opportunity. So the more advanced methods of doing that are what we now call Industry 4.0, or what I call data-driven manufacturing, which we've been doing in the auto industry for decades, is having sensors and information about the parts coming through the process. So if I have a part, I have a birth history, so to speak, so I know every step it goes through and time stamped so that I can see if it went all the way through. We get that information back in a computer system, we can analyze it. One of the examples that I'll have is in transmission manufacturing. We put in a new system to where every transmission had to go cleanly through the process. If it became rejected anywhere in the process, it was stripped down and restarted. Well, that creates some issues. First off, that you're scrapping the parts or returning them back to the beginning of the line to get reassembled. But what happened in that process is over time, we realized that the output of the process was getting lower and lower and lower. So I was asked to go in and evaluate, what's going on here. And through that data and analysis, we started realizing that we weren't identifying what was the culprit part of the assembly. They were just getting put back to the front of the line again and reassembled. So that part, every time it would come through in a new transmission, would fail again in the same place. So we had to put methods in to track those repeat offenders and get them out of the system to get our output back up again.
When you say we, what was usually your team consisting of? Or
myself, other engineers, people in the plant, the operators on the floor. The operators on the floor are key. Those people know everything that's going on, and if you create the best culture around those folks, you can really have a win.
Yeah, absolutely. Before we got on the show, we were talking about the conditions and the way things have changed over the years as far as the landscape and the cleanliness of really what goes into an automotive factory. Can you share a little bit about that? What you've seen over your career?
Sure. When I first started in the automotive industry, it was the typical of what people think: very dirty, oily, mist, fog in the air, dark. But over the last several decades, it's really changed. I mean, when I was last in the automotive industry in 2014, I mean, the factories were clean, they were quiet, they were well lit. It was a very enjoyable work experience, very high tech. The auto industry has had to be right on the cutting edge of technology forever because of this. The typically low margins in automotive. They need every ounce of help they can get. So what we call data-driven manufacturing or 4.0, that was started in the 80s and 90s in automotive. So a lot different than what people think of automotive manufacturing.
Yeah, and on that note, I guess one of the questions I have for you, Paul, is what do you think really made that transformation from kind of this dirty environment, probably what we would consider substandard working conditions for the people on the factory floor, to this, what sounds like a very great manufacturing job opportunity, right? You've got well-lit, clean spaces that you're working in, low noise, which is good for long-term health of the employee. What really drove that change? Was it some of the recent sustainability stuff? Was it more the margins? What do you think contributed to that?
There's actually several reasons. I mean, people is obviously one, sustainability and the environment is another. But I think over the time, especially when we started getting into Six Sigma and some other things, we started realizing that there are impacts to having a dirty environment, especially in something like a transmission or an engine, where the dirt in the product creates a problem overall, or a lower lifespan of the product, or rejects in the assembly system. So creating the clean environment helped. We got rid of cardboard and started going to returnable dunnage. More light improved the ability to get the work done properly and see what was going on. And the noise level, that helps the worker's environment too. But when you think about it, if we have above 80 dBA sustained, we have to have hearing protection. So there was a drive to get away from hearing protection zones in the plants, and that led to design of equipment changes to get the equipment noise down to where we could have that lower level of noise in the environment.
Incredible.
So in your work environment that you were at, they didn't require hearing protection currently?
No.
You don't have.
Not in the automotive industry, but in other industries, it's still noisy and it still requires hearing protection.
Yeah.
I don't remember the last time I was in an industry that didn't have to put the earplugs in. Wow. That's
I've been in a quiet factory, and there's something a little eerie about it for me because of the industry I grew up in. So industrial packaging, and most specifically, the reconditioning business within kind of that whole space. And it's very loud, it's very dark, it's very dirty in general in the factories I've been in. And then, of course, there's some that are more advanced. But as I travel to different facilities and see different types of manufacturing operations, it's almost a little bit unsettling when it's so quiet, so clean, and so light.
Yeah, that's amazing. So changing gears a little bit, you did some stuff with, you mentioned Lean Six Sigma earlier on. Mm-hmm. And I imagine that, I know the automotive industry was kind of, it was maybe Motorola, but I'm pretty sure it was well adapted probably back in the 80s, 90s. Is that where you saw it start getting value into it?
Six Sigma actually came into Ford around 99, 2000, and that was based on GE. GE started, Jack Walsh, and they had a lot of success. So Ford picked it up, And with working with the Six Sigma Academy, created the infrastructure within Ford.
Yeah. Well, TE is true efficiency. So it's tracking the product from when it's first conception to when it's, I guess in your case, being rolled off the assembly line. Yeah.
Oh, I was just going to say, what are some of like the biggest Lean Six Sigma projects that you've been a part of, Paul, at Ford or any of your other past lives? And what's something exciting somebody could take away from that?
Oh, there's many. And then as a master black belt, I was also, mentoring lots of other black belts. So there's hundreds of projects that I've been involved with. Some things as simple as, figuring out why, a planetary gear system isn't making it through the final check, and then working it back to finding that there was a burr on the parts, which is going to be normal because they're stamped. So, and then we changed the tooling so that it avoided the burr. That was kind of a simple one.
That's cool.
Other ones were a lot more complicated, where we would have gear noise in a product on a coast down, and we went into a lot of design of experiments to understand what the geometry of the gear teeth was. So, and then we would modify that so that it would reduce the noise ultimately.
That's cool.
Another thing that I guess I had done research on, and I know automotive is very much into it, is failure mode effects analysis. Have you been part of I've only done it in the food industries, and I would have to say I can't say we perfected it, but we've tried it. Can you walk me through what does an automotive process look like when they do the FMEA?
Sure. FMEA, failure mode and effects analysis, there's many different types. There's design, so going through the product itself and understanding what are the failure modes that can happen in this product, and how do you mitigate them if they have a high, what they call a risk priority number. That's an evaluation of the individual failure mode. There's also process failure mode and effects analysis. So as you're producing a product, going down through the process, what could go wrong in the process to create an issue, either that it gets rejected or that it ends up as a failure in the customer's hands. And then I take it a couple more items, being involved with manufacturing, engineering, and building machines. I do a machine FMEA. So it's kind of a design of the machine or the automation system to identify what can go wrong with that, and then design that out. And then the larger picture I call a system FMEA. So if I have an entire system that's generating a transmission or something else, what could go wrong in that system, not just with the parts, but say with the ERP system, the MES system, SCADA, and then how do you get around that? Or if you have a, God forbid, a data breach and you have to run dark, how can you do that? So that's another level. So you can do a FEMA pretty much at any level or any part of the process or product that you want, but it's all about thinking about what can go wrong and how do you fix it. I like to give examples of, I like my engineers to have a FEMA mindset at all times. And I typically use the example of, if you see your mom getting up on a swivel chair to get something out of the top of the cupboard, you should be thinking that that's probably not a good idea, and take that chair away and hand her something that's stable.
Yeah.
That's the whole concept of a FMEA. Just try to do something better.
Yeah.
Such a great visual. I think everybody in the audience can picture that vividly and is cringing as I was as you were talking about that. So
I'll have to pocket that one. Yeah.
Yeah. Yeah.
So the other thing I want to ask you about is patents that you have out there with some major automotive companies. You were sharing a little bit about before we started the recording, but if you could share with the audience some of the process improvements that you've developed over the years, I think it's very fascinating.
Yeah.
There's a couple of them. There's when I was working in the what we call rapid manufacturing, it's essentially 3D printing. One of Ford's commercial labs, we had sand printers so that we could print molds to go and make castings with. We were working with stamping operations, and if you can imagine on a stamping die, say for a hood, you have the part that forms the hood, then there's some folding going on, and then there's some trimming. So when it has to shear off the metal, those are called trim dies. We worked with stamping operations to make those trim dies, and we advanced the process to where we cut half of the steps out and got near net shape. But part of that was taking the design information from the stamping engineers and then translating that all the way down to what is needed in the model for this stamping die. And the team that I worked with, we generated an automated CAD process, so to speak, that went right from the design information from stamping to a model that we could then go cast. And then beyond that, it took that cast model and generated the model for the sand printed mold, and we could go right to the machine with it. So that was one of the patents. Another patent also related to casting is when you try to cast a steel component into an aluminum casting, like cylinder sleeves, steel cylinder sleeves into an aluminum engine block, you have to heat the steel first before you pour the aluminum. Otherwise, you'll get a bad casting. So typically that's done with induction heating coils. Well, if you're only making a couple of castings, that can be very expensive to try to do, and it becomes prohibitive. So we came up with an idea, or I came up with an idea with another gentleman that we proved out, is we did a double pour. We generated the mold for the engine block using, again, 3D printing sand technology to make it available to be able to do. And we created pockets in the areas that we needed to heat the steel. So we would first pour the molten aluminum into those pockets, and we waited approximately 2 minutes. This was a design of experiments we had to do to figure out how long. And then once that heat generated through the steel and heated the steel up, then we could pour the engine block, and we got good castings. So that's another one of my patents.
Okay, so one question about that, and I was thinking of this when we were talking about it a second ago before we started the recording. So do you just clip or cut the additional aluminum, the pre-pour, like the first pour off, and then sand that down? How does that work?
The pre-pour actually isn't part of the engine block itself, so that comes right off. When you break out the sand mold, that pre-pour, so to speak, is its own piece. That comes off.
I was picturing it as being connected and then having to be cut off at some point. So I'm glad I asked that question. That was burning curiosity of mine there.
Yeah, think about in the cylinder having a cup, so to speak, that's made of sand, and pouring the molten aluminum into the cup, and it's just sitting there and heating the steel.
I see.
And then once it solidifies, that steel or the molten aluminum inside that cup just comes out.
Cool. Do you guys recycle the aluminum, I take it?
The foundries do, yes.
That's cool. Nice.
Yeah, otherwise I'd take it.
I know. I was like, aluminum is like like that is a very good metal to scrap. And don't get me started on that. But okay, so I have a question for you, Paul. As we're thinking about, the current state of the automotive industry, thinking about the worker who's on the factory floor, I'm always concerned with the worker and what they can do to ensure that they have, a good job and career trajectory, regardless of what position or role they're in. So it's clear to me that obviously there's a lot of technology and advancements within the automotive industry. I'm, I guess, an unusual brain in thinking that the automotive industry is very advanced compared to what you're used to hearing or having to correct people's preconceived notions about. So what could a factory worker do to ensure that they have a spot on the floor in the next 5 years with additional robotics, AI technologies, and things coming into play?
Okay, first let me say that the advancements in technologies, contrary to popular belief, have never taken jobs away. If you look at the industrial revolutions from the past, first, second, third, now the fourth, and the fifth is coming, in every situation, people thought, the jobs are going to go away, and actually the opposite happened, right? There were more jobs, more needs. And typically, the reason, or one of the reasons for that is when we introduce technology, it gives us the ability to then do more. So that we still need people, and if we're doubling our output, there's a good chance we're going to need at least 50% more people, maybe not twice the number of people, but we're going to need more people. So to keep on that bandwidth, I mean, the team members, it's an exciting time when you start to do automation. And if you have a knack for wanting to do something like that, you can either be around the automation, working with it. You can learn to program and become a technician or a robot programmer. There's all kinds of things you can get into, and it's an exciting time. I mean, we went from back in the early 1900s of somebody putting spokes in a wheel, right, for a Model T, and that's all they did. And if they didn't do it right, they were fired. Where now, if your job is going to be automated, And it's not, I shouldn't say that. Your job is not going to be automated. Automation takes tasks. The job, you can almost never automate a job. You can automate certain tasks of the job. And typically what we try to do is we automate the parts of the job that the people don't like to do anyway. So their job becomes more enjoyable because, the robot's going to do that thing that used to hurt my shoulder, but I'm still here and I get to play with the robot too. I'm learning how to program. I'm learning how to reset points and stuff like that. So just be open to learning new things and having fun with it, because it's not going to take jobs.
I agree with you. And I mean, one of the things AW was smart to bring up earlier this year on one of our shows is we're short 2 million people in the workforce today.
Exactly.
Right? So that problem is not going away. If we increase manufacturing here, if we continue to do these things, that number only goes up, and we need to create solutions for this. So if I put a bow on what you're saying, really, be open to learning, trying new things, communicate your interest to your supervisors, your factory managers, and show a little initiative and interest in the new process being put in place. That'll probably ensure long career in manufacturing. Cool. Thanks, Paul.
Yeah. In fact, in my recent past, we were really trying to go after automation as fast as we could because we couldn't get enough people. We couldn't make the output that the plant wanted. So we were trying to figure out, okay, how do we reduce the need for the unskilled labor, just to be able to put the product out.
Right.
And we were working with the people on the floor, and it's like, okay, you're here, we're going to automate this. Do you want to become involved and learn how to program a robot? And most of them said, yeah, that sounds interesting.
Awesome. That's great to hear that people are interested and on board with learning and taking the next step there.
Yeah, we tend to hear similar stories too, that like Paul is at, even just in different industries, the automation is not taking jobs.
Yeah.
Just a different landscape we're seeing it put on. Paul, as we're bringing it to a close here, if folks want to reach out to you, is there a good way? Do you do LinkedIn? Is there some place that they can contact you?
Absolutely.
LinkedIn. Yeah. And we'll put it in the show notes so they can connect with you if they have some more questions about it, because you got a wealth of knowledge, and I'm sure that different industries or similar industries may have some other questions that they could offer to you could bring to them. Alexandra, do you have anything else you want to bring up?
I was just going to ask Paul, what's next?
Well, good question. Yeah.
I don't know. More, bigger, faster, right?
Okay. I like it. That's cool.
Try to find the next cool thing to work with, and again, it's got to make sense for the business and the economy and the world, right?
Yeah.
Research for research sake doesn't get you very far. Research for implementation into the plants to make an impact, that's where it really makes a difference.
Well, I think your lasting impact, it lives through the patents that you created, and I wouldn't have a doubt in my mind that there's more of that to come. So best of luck with that.
Thank you.
Yeah.
All right. Well, let's come to a close. This is Factory of the Future, and we are checking out of here like finished goods.
Clocking out.
This is Factory of the Future, and we are out of here like finished goods. Stay tuned for our next episode of Factory of the Future, where we're exploring groundbreaking techniques and behaviors that are reshaping industrial landscapes. Don't forget to subscribe and leave us a review and help others discover the cutting-edge insights transforming manufacturing as we know it.